Hello everyone. We'll see today uh, some topics about hydrothermal scheduling. So today's topic is hydrothermal scheduling. So we know that there are a variety of power plants. So we have a hydropower plant, we have a nuclear power plant, and we have solar, we have wind, and we have thermal and so on. So all these are different varieties of energy sources from where we can produce energy. Now, commonly used power plants are hydro and thermal. But in a large power system, we have integration of hydro and thermal to meet the demand. So as the power system as the power demand increases, we have to integrate different types of sources or different types of power plants. So normally that will be done with hydro and thermal. So we have integrated power systems which is a combination of hydro and thermal, and in this chapter we'll be seeing how hydro and thermal scheduling will be done. So in a large power system, I said hydro and thermal power plants will be integrated in order to meet the demand. So the combination is to meet the demand. Such a system is more complicated than scheduling an all thermal systems. So normally if suppose we have only thermal system, then it will be easier for us to schedule, but combination of hydro will and thermal will have more complications, since we have to consider different constraints. Thermal power plants are normally thermal power plants have less capital cost. So if I compare thermal power plant and hydro power plant, I can note down few points here. So thermal power plant has less power plants have less capital cost, but their operating cost is very high. Operating cost is high. Whereas if you see hydropower plant, hydropower plants, these have a huge amount of capital cost, or we can say capital cost is very high, but the operating cost is less. Operating cost is less. With respect to capital cost and operating cost, we can say that the thermal power plants are having very less capital cost and hydropower plants are having a very high capital cost. But with respect to operating cost, the thermal power plants operating cost is high, whereas the hydropower plant is having less operating cost. But the hydropower plant has some other advantages. So if you see, hydropower plant can be started very quickly. So hydro can be started quickly and has greater speed of response. So response is very fast. And this is used for controlling fluctuating loads. Controlling fluctuating loads. And thermal power plants start slowly and response is also slow. So response is also slow. Due to all these points, thermal power plants normally referred as base load plants, and hydropower plants are referred as peak load plants. So, about thermal power plants and their scheduling we have seen in power system analysis too, and in this chapter let us see the combination and also the scheduling of the combination. But before that, let us see the advantages and disadvantages of hydropower plants and also the scheduling of hydropower plants. So, the advantages basically are many. So, let us see few advantages of hydropower plants. So, it is a renewable energy source. So, the source or energy source is water here. So, it is a renewable energy source. And the second one, second advantage is it is fast, it's fast response to fluctuating load. So, as I said earlier, the response is very fast, and since the response is fast, it is used as the source for fluctuating loads. That is why we choose or select hydropower plants as the peak load power plants, So, it also promotes guaranteed energy and price stability. Since it is not dependent on market instability or market fluctuation, it promotes guaranteed energy and also price stability. Always there will be stability in the price. And since many of the hydropower plants are having reservoirs, reservoirs perform additional job of collecting rainwater. So, there will be abundant energy source, that is a water, and a few of the hydropower plants are having reservoirs. So, they can collect rainwater as the source of energy. And since the response is fast, it increases the stability and reliability of power system. So, very important parameter with respect to power system is the stability and reliability. So, the hydropower plants response are very fast, so that they can achieve easily or they can increase the stability and reliability of the power system. And it is eco-friendly and clean, sustainable and cheap energy source. And the hydropower plants are having few disadvantages. So, let us see what are the disadvantages. So, the capital cost is very high, or you can say the initial cost is very high, and these are the hydropower plants are dependent on rainwater and rain and monsoon sometimes, or you can say where there is less water sources, the area is dependent on rain and monsoon. The construction of dams can affect land and wildlife habitat. So, for hydropower plants we need to construct dams. So, the construction of dams can affect land and wildlife habitat. So, it can also cause displacement of local population. So, these are the few disadvantages of hydropower plants. So, let us see the classification of hydropower plants. So, before we see classification of hydropower plants, let us see different types of turbines used for hydropower plants. So, most of the hydropower plants use reaction type of turbines for low and medium heads, and for high heads they use impulse turbines. Examples for reaction type turbines are Francis and Kaplan turbines. These are reaction type of turbines, and these are used specially for low and medium heads. And at full gate loading, they give efficiency of 85 to 90%. And for high heads, impulse turbines are used. An example for impulse turbine is Pelton turbine, and they give efficiency at full gate loading at around 70 to 87%. And to make the best use of hydropower plants, we need to operate it near the maximum efficient point, for which the required head is necessary. So this has to be operated at a low and medium heads to get this much efficiency, and if you are using Pelton turbines, has to be operated at this level to get 70 to 87% efficiency. So let's see the classification of hydropower plants. So there are two types of classification. One is classification based on the type, classification on the basis of type, and the second one is classification on the basis of location. Classification on the basis of location. So on the basis of type, we have again two types of power plants. One is conventional power plant and the second one is pumped storage power plant. Conventional power plants are again classified into two types. One is a run-off river plant, which has a little storage capacity, use water as and when it is available, and the unused water is spilled away. So this is a run-off river plant, and the storage plants have storage reservoirs. So these have storage reservoirs. These have storage reservoir. So these will use little storage capacity. And pumped storage plants are having two reservoirs, one upper and lower, two reservoirs, upper and lower. The light loads, water is pumped from lower reservoir to upper reservoir, and during peak loads, water stored in upper reservoir is released to generate power. So this is how the classification is done based on the type, and also the storage plants. These will have storage reservoirs, and these store water when power required is low and release when demand is very high. So these release water when demand is high. So this is based on the type, classification based on the type, and second one is classification based on the location. So classification based on location, we have three. So first one is plants on different streams, second one is plants on same streams, and third one is multi-chain. Plants on different streams, where the plants are connected to common load but are located on different streams and are independent of each other. So these are connected to common load, connected to common load but located on different streams. Plants are on same streams, these are connected cascade, and multi-chain is combination of the above two. This is actually the combination of these two. So this is based on the location. So let's see what is scheduling of hydro systems. So power developed in a hydro plant depends on the water head, depends on two parameters actually. So first one is 2 points, 2 factors. So first one is water head, and the second one is the discharge, that is water discharge. So the power developed in a hydropower plant depends on these two parameters. So first one is water head and the second one is a discharge. Head is actually, in this diagram it is shown, head is actually the vertical distance between the starting point and ending point, where starting point is where the water begins to impact the pressure on the turbine, and the ending point is where it ceases to exert pressure on the turbine. So, here the starting point is where the water begins to exert some pressure on the turbine, and here it ceases to exert pressure on the turbine. And normally a low head site is nothing but has a head of around 10 meter and above 10 meter and below, and a high head site is has a head of 20 meter and above 20 meter. So, these two are the very important point, water head and discharge, and the very two head classification is, one is 10 meter and below, that is the low head site, and if the head is 20 meter and above, then it is high head site. And I said head is nothing but the vertical distance, it is always vertical distance from the starting point to the ending point. Starting point is nothing but where the water starts to put pressure on the turbines, and here it ceases to put pressure on the turbines. So, the hydraulic power can be given by PH, which is equal to head into flow into acceleration due to gravity. Acceleration due to gravity. So, this is hydraulic pressure. So, this is hydraulic power, and head is in meter, head is a vertical distance. So, this is in meter, and flow is the water flow. So, it is liters per second, and acceleration due to gravity is, we take this value as 9.81, and the unit is meter per second square. Now, whatever hydraulic power is there, it will not be completely converted to electric power. So, there will be some wastages that depends on the efficiency of turbine and generator. So, we can expect about 50 to 60% of system efficiency of turbine and generator both together with the system efficiency. Therefore, suppose if I take an example, say the hydraulic power calculation, if I take for a 10 meter head and the water flow is 20 liters per second, and acceleration due to gravity is 9.81, we will be getting hydraulic power of 1962 watts for this example. And if I consider about 50 to 60% of efficiency, then we will be getting the generated electric power due to hydropower plant is around 1178 watt as electric power. So, in general, generated electrical power is given as PGH is equal to efficiency into rho into Q into G into H, where rho is efficiency of the system. Let me write in the next page. So, we have PGH, that is generated electric power from hydropower plant is nothing but rho, efficiency eta rho Q, G and H, where this is system efficiency. When I say system efficiency, both the turbine and generator efficiency is considered together. So, this is system efficiency, and rho is nothing but the density of water, in kg per meter cube. Then Q is nothing but water flow, and I say the unit is meter cube per second, and G is the acceleration due to gravity in meter per second square, and the value is 9.81. H is the head in meter. H is head in meter. And the unit of PGH is, it is a generated electrical power, so the unit is watt. So let us take a simple example for the calculation of electric power generated. So I said the equation is electric power generated from a hydropower plant as PGH is equal to efficiency and rho, which is density of water, and Q, that is water flow, and G, that is acceleration due to gravity, and H, head. So efficiency is actually system efficiency, but here two different efficiencies are given for generator and turbine. We have to take the combination. So PGH will be here 0.89 into 0.85. So this will be the combinational efficiency. Then rho is density of water, and density of water is 1000 kg per meter cube, and Q is water flow, so 0.095 meter cube per second. So check for the units. All these must be or should be in the standard quantities. And we have G is 9.81, and water head is given, it is 150, and if you calculate this, you will be getting 105,753 watts, or I can say it is 105.753 kilowatt. This is a simple example for the calculation of electric power generated from a hydropower plant.